answers. Write only the answer. Don't write 2, 3, 1, whatever it is. Only write A, B, C, D. A, if for the first answer is A is correct, then you write A only. Don't write 3, 8, 1. If the second answer is B, then write B. If the third answer is C, then write C. Then if it is D, it is D. So you have to write it only the options, correct options. Don't write anything extra. Okay, got it?
Yes, sir. Yes, sir.
So start writing, and when you done 1 and 2, then let me know. I will scroll it up. Okay. Take out your copy, everyone.
Okay.
Bye. When you done, please let me know. 1 and 2 done.
Yeah. Yes.
Do 3 and 4. Do the third one and the fourth one.
So can you go again on second one?
Done, everyone?
Yes.
Hmm? Done?
Yes.
Okay, next. Do this one. Do the third. Do the fourth one.
So we don't need to do the third one.
Yeah, you have to do.
Okay.
You done?
Yes.
Do the sixth one. Fifth and sixth. Do fifth and sixth. Done. Done 5, 6. Why are you
Yes.
not replying? Everyone?
No, sir.
Done 5,
Yes, sir.
6.
No.
Done.
Sir, just a second for 16. Yes, sir, done.
7th. Done 7th.
No, sir.
Just a minute. You done 7?
Yes, sir.
Tell me.
Yeah.
Yes, sir.
Do the 8 one. Done? Done question number 8?
Yes, sir.
ये क्या आ गया? Do question number 9. Mass you know na? Mass is neutron plus proton. Number of neutron plus number of proton, that is mass number that we have discussed. So note it down and do it. Question number 9 done?
Yes. No, sir.
No. When you done 9, then let me know. Then you have to do the 10 one. Done? Do question number 10. Done question number 10.
No, sir.
Speak a little bit louder. Everyone is silent. Why it is so? When all the 4 students are going to answer me, then I'm going to scroll up. Otherwise, I will keep on these questions, and you have to do only one question. Same. If you are not replying me,
So can you scroll up to the 10th question?
with the 10th one.
Yes,
Yeah.
sir.
Done.
Do the
Done,
11th.
sir.
Done 11.
No. No.
Done, sir.
Others?
No, sir.
Done, sir.
Yeah.
Hafsa, are you there?
Yeah, I still am done.
Do 12, 13 and 14. Done? 12, 13,
Done, sir.
14?
Yeah.
Other students done?
Yeah.
Done everyone?
Yes, sir. Yes, sir.
Do 15. Aluminium has atomic number 13. Do 50, 16.
Done, sir.
Done 16.
No,
Done, sir.
sir. No.
Doing. Do it.
Done.
Done?
Yes.
Yeah.
Okay. Do 17. Do it fast.
Done.
Done.
Yes.
Yes, sir.
Do 18. Done.
Yes.
Okay. Next is, let's you first check the answers up to here. Just a minute.
Sir, I have a doubt.
Yes.
Sir, can you scroll up to the 18th question once again?
Which question?
18th question.
18 questions. Here it is.
Here they're asking atomic models and the people, and they give names of people who gave the atomic models. Like we can consider John Dalton as one as well. Yeah.
John Dalton and?
We can consider him as well, right? In these names.
No, according to your NCRT that you are going to study these three models, so you have to write the names of these one only. Okay, but model was first given by Thomson, then after it was given by Rutherford, and then finally Bohr model we used to study. So that's answer will be uh second,
Mm.
then first, second, first, and C is the correct option. Okay,
Yes, sir.
so you have to check your answers. Just a minute. So please check your answers from here.
Answer.
Done, everyone?
Yes.
Okay.
Yes, sir. Yeah.
Now tell me that from the first five, how many of yours are incorrect? First five. Speak a little bit louder.
First five, I got the
Just a minute.
third one.
Sorry, let me plug in the headphone because you are speaking so low that I can't hear you properly. So just a minute, let me plug in the headphone. One minute. Yes. Yes, try to speak. Is your one is correct or incorrect? First one.
First one's correct.
Second one.
Correct.
Correct or incorrect?
Correct. Correct.
Third one. All of you?
Correct.
Incorrect.
Correct.
Incorrect.
Incorrect. Okay. So,
Incorrect.
okay. So here it is saying that the number of electron present in an atom is 15. X element is 15. So electron is 15. So proton will also be 15. Okay. So if it is 15, then what is going to happen here is that if it is 15, so electron is 15, then proton is also 15. This is the rule for an atom. If it is electrically neutral, then it will be electron and proton should be equal in number, because otherwise atom will not be electrically neutral. So for a neutral atom that is not going to have any charge, you can see that if it is Na positive, this is not a atom. It is not an atom. It is an ion. It is having charge. But if I'm writing sodium, so it means it has 11 electron and 11 proton, electrically neutral. So, and you know that the mass number is due to proton plus neutron. Okay, proton. So what is saying here is that the electron is 15 and the number of neutron is 16. So atomic mass will be equals to, this is the atomic mass. Proton plus neutron is atomic mass. Atomic mass. So you know that if electron is 15, then proton will also be 15. So 15 plus 16. 16 is neutron. You will get 31. So when you write an element here at the bottom, you write the atomic number. That is either the number of proton and number of electron. So you write 15 here because it is proton equal to proton. Okay. So proton will be written here. Number of proton will be written here, or the atomic number, we called it atomic number. Okay. And the sum of proton plus neutron will be written here. That is mass. That is 31. So the correct answer is 15 at the bottom and 31 at the top. A. Got it?
Yes, sir. Yes.
Next one. Which one of yours is incorrect? Can you tell me?
It's correct.
Fourth is correct or incorrect? Fourth.
Correct. Correct.
Correct. Everyone.
Yes.
Yes, sir.
Fifth. Correct or incorrect?
Incorrect.
Fifth is incorrect. Fifth is
Correct.
incorrect. Okay. If fifth, why fifth is incorrect? Let me check. Which of the following statement of Rutherford models are correct? So Rutherford, you know that Rutherford says that most of the alpha particle passes straight. So consider the nucleus is positively charged. Yes, he said that nucleus is positive because nucleus was discovered actually by Rutherford. And he said that electrons revolve around the nucleus. It is only possible if we put the positive charge at the center. So this is the correct statement. Establish the alpha particles as 4 times heavy than hydrogen. No, alpha particle is actually 4 times. Yeah, it is doubly charged and its mass is 4 and atomic number is 2. So establish that alpha particle are 4 times heavier than hydrogen atom. Yes. because hydrogen atom is actually okay. But
Sir,
just a minute. It is statement is correct, but alpha particle is 4 times heavier. Okay. But here it is saying that we have to choose only three. He compared with the solar system. Yes, it is absolutely correct. Means he says that actually that the electrons revolve around the nucleus. Okay, and was an agreement with the Thomson model? No. So if we have to choose the two options, so we have to go with first and third, because alpha particle is 4 times, but he does not means that is not related to the structure of atom. So we are just going about the Rutherford model of atom. So what to say about this one alpha particles? We are just describing that nucleus is a part of model, okay, and this rotation of electron around the nucleus is a part of model, but alpha particle is not a part of model. That was a part of experiment. Got it? Got it? So that statement is correct that alpha particle is 4 times heavier than the hydrogen atom, but it is not a part of model. It is a part of experiment. You got it? Understood? So we'll go with the first and third. Understood?
yes, sir.
Yes or
Yeah.
no?
Yes.
Next, is there anyone? 6 is correct.
Sir, I was
Correct.
wondering if you could explain that because I didn't do that one.
You speak a little bit louder because my headphone is not working. I think so.
I didn't do the sixth one.
You didn't do the sixth one, so let me explain you now. So you know that because I think I have not taught you this portion, proton plus electron atomic number, such that I just come to know. I just remember this one. I just teach you only the three models, but not I've not teach you this one. I think so. That's why I'm sorry for that one, but it's okay. I will teach it in differently. I'm going to explain you here also. Okay, don't worry. So atomic number is equals to the number of proton. Yes, atomic number is absolutely equal to the number of proton or number of electron for a neutral atom. It is also equal to number of electron. But proton, since why we are saying that atomic number is equal to proton and why we give the preference to the proton? Because proton always remain in the nucleus and it does not leave the atom or gain or added to the atom. But the electrons can leave the atom. Like for example, if I'm saying sodium positive, so it means sodium initially have 281 electronic configuration, but it has loosened one of its electron. Now it is Na1 positive because it is having still 11 proton, and initially it was having 11 negatively charged electron, and that's why its total charge is 0. But here, since it has donated one of its electron, still it is having 11 proton, but now it is having 10 electron only, 10 electron. So that's why it has 11 positive and 10 negative. So overall you will have one positive charge. So what does it means? What does it means? It simply means that we just when we are just giving the I mean the preference, or we can say that when we are just saying that the atomic number is equal to the number of proton, so it is absolutely correct because proton will always remain in the nucleus, even though if an element is losing its one electron or gaining one electron. Like for example, chlorine become 288 when it gained one electron. So initially it was having 287, but when it gained, it require one extra charge because it is still having 17 proton and 18 electron, because one electron has been extra, it acquires. Okay, so it has acquired one extra electron, so that's why it require one's negative charge, and for positive you will get one negative charge extra. But still its atomic number is 17. It does not mean it is having 18 electron right now, its atomic number will change to 18. No, its atomic number now this time will be decided by the proton. So for an ion which is carrying charge, the atomic number is only determined by the number of proton. But for a neutral atom, we can say that it is equal to the number of electron also. So atomic number is equal to number of proton, but number of electron, no, it is not. Plus is not there. Atomic mass number is equals to number of proton plus number of neutron. This is absolutely correct. Number of mass number on atomic mass is the same thing. Atomic mass and mass number is the same thing. Don't get confused. The number of proton plus number of neutron is same. Correct. Atomic mass is equals to number of proton. No, it is a summation of proton plus neutron. So that's why it is incorrect. Okay. Atomic number is equals to number of proton is equals to number of electron. For a neutral atom, we can say that it is correct. So if we have to choose the two options, so we'll go through this one. So because proton and electron in a neutral atom are equal, so that is also equal to there. But initially we can say the number of proton is equal to the atomic number for all kinds of atoms, whether it is a positively charged or negatively charged, means ions or a neutral atom. Are you getting my point? Are you getting my point? Yes or no?
Yes.
Yes, sir.
Everyone?
Yes.
Okay.
Yeah.
Let's move to the next one. Is 7th is correct for everyone?
So I
Incorrect.
got it wrong.
You got it wrong. Okay, let me explain you. In Thomson model, which of the following statement are correct? The mass of atom is assumed to be uniformly distributed over the atom. The mass of atom is assumed to be uniformly distributed. Uniformly distributed means, yeah, that the mass is uniformly distributed. Or he said that the positive charge is uniformly distributed because the center of nucleus, the concept of nucleus was given by Rutherford. So according to the Rutherford, the whole mass is concentrated in the nucleus, but according to the Thomson model, there was no nucleus. So he said that the whole mass is distributed over the sphere. That is also the charge. Okay, and it is uniformly distributed according to the mass of atom is assumed to be uniformly distributed. Yes, it is correct. The positive charge is assumed to be uniformly distributed over the atom. Yes, it is also correct. The electrons are uniformly distributed on the positive charge sphere. This is also correct. Electrons attract each other to stabilize the atom. No. Electron attract each other to stabilize the atom. No. Electron do not attract. Yeah. Electron repel each other. Why do they attract each other? So 1, 2nd, and 3rd. A is the correct option. Got it?
Yes, sir.
Yes.
Next one. Next.
Correct.
8 is correct or incorrect?
Correct.
Everyone.
Sir,
Correct?
correct.
Everyone?
Correct.
9th. Correct, incorrect?
Correct.
Everyone? Everyone correct?
Yes, sir.
10th one. 10th one. Tell me, most of the students are going to have these questions, means they might have done wrong. So
Incorrect.
I
do
got
you
it.
have, I mean, have you done this one correct or incorrect?
Incorrect.
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 So the reason here it is saying Mg2 positive. What do you mean by Mg atom? Mg is magnesium. It is going to have 12 atomic number and its electronic configuration is 2, 8, 2. But what is the difference between Mg and Mg2 positive? The 2 positive charge came when an element, positive charge came when an element is going to have more positive charge or more number of proton as comparison to the number of electron. Okay. Or we can say that difference of the proton and neutron is plus proton and electron is 2. Proton is more because the positive charge is having positive charge, so it is having more proton as compared to the number of electron. 2 more proton, exactly 2 more proton than the number of electron. That's why it is having. So initially it is having 12 electron and 12 proton. But if it is acquiring 2 charge, it means it is having still 12 proton but 10 electron. That's why it is having 2 positive charge. Okay. Are you getting my point? Getting my point? Yes or no?
Yes, sir.
Yes, sir.
So it means it has donated. Here it is having it has donated 2 of its electron and formed 2, 8. Means there are only 2 shells. The first shell is going to have 2 electrons and second shell is going to have 8 electrons. So we'll first discuss this one. That's because it is Mg2 positive. It must not have 2 shells. This is the nucleus. Blue color is nucleus. So it is having 3 shells. So we cut it. This one model is also having 3 shells. We'll cut it. These two are having 2 shells. Okay. But since the first shell is going to have 3 electron, that is not practically possible. The second first shell can have maximum 2 electrons. According to the rule of 2n square, you will write 2, 1 square, you will get 2 into 1, that is 1, you will get 2. So simply you will get 2 electron in the first shell. So it is incorrect. And this one is correct. Moreover, it is having 10 neutron. It is not. Magnesium has mass 24. But since it is not representing the mass number here, let it be. Mass number is not represented here. So we'll go through this one. Got it? So 12 proton, 12 neutron, 12 proton will be there because magnesium has 12 mass. Okay. And 12 neutron. It is neutron also remains same in the nucleus. So the proton and neutron together in the nucleus are called nucleon. Nucleon. Understood? Yes or no?
Yes, sir.
Yes or no? Okay. Next. Do question number 11. Sorry, you done question number 11?
Yes, sir.
Was it
Yes.
correct or incorrect?
Correct.
Incorrect.
Correct or incorrect?
Incorrect.
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 So what is saying that a sample of ethyl ethanoate is the name of this compound, has two oxygen atoms, have same number of electron but different number of neutrons. So if an element is going to have different number of neutron but electron are same, so it means that it is isotopes. Isotopes are the element that has different masses like carbon 12, and carbon 14. Carbon 14, but their atomic number are same. Means atomic number same means proton and electrons are same, that is 6. So if it is having 6 proton and the mass is 12, so it means it must have 12, 6 proton plus 6 neutron. Proton plus 6 neutron, that is going to have 12 mass. Because it is having 6 atomic number means 6 proton, fixed, it is fixed. And second one is if an element is going to have like I'm explaining you here with the carbon, but we have to explain it with the oxygen. Okay, so if it is having, I'm saying carbon, so it means it must have same atomic number. 6 must be same. Because two same element with the same name cannot have different atomic number. If the name is carbon, then they must have same atomic number. So what they can have difference is neutron. If it is having 8 neutron, 6 proton, and the mass will become 14. 14. So same here, you can consider this one that if it is, I'm saying that this is 1 and 2. So what does it means? This is 1 and this one is 2. What does it means? That the two oxygen atoms have same number of electrons but different number of neutron. Which of the following statement is correct? So if they are having different neutron, though they will be isotopes, because different neutrons means different mass. So one oxygen atom has gained electron, no. One of the oxygen atom has gained 2 neutron, no. It is not mentioned. Yeah, 2 oxygen atoms have same, so 2 neutron is not mentioned. The oxygen atoms are isotopes. They are called isotopes. Got it?
Yes,
Got
sir.
it?
Yes.
Next is
Yeah.
the element. Is it correct? Question number 12.
Yes, sir.
Incorrect.
Incorrect. The element with valency 1 is considered to be as metals, or it can be non-metal also. Like for examples, if I'm going to explain you, you don't know what is metals and non-metal. You might not know. It might be possible because you have not studied this one in the 8th standard, and I have also not taught you this one till yet. So elements, but I have sometimes in the, I think so. No. In the second chapter, I have discussed this one in elements and compound, that elements are divided into two broad categories. One is metals, another one is non-metals, and third one is metalloid also. But we generally consider this one metals and non-metals. So if there is 1, 2 or 3 electron in the outermost shell of an atom, then it is considered to be as metal. If there is 4, 5, 6, 7 electron in the outermost shell, then it will be considered as non-metal. For example, if I'm saying 281, the one is the last electron in the shell, then it is metal, that is sodium. If I'm saying this is potassium, 2881, electronic configuration, 1 electron in the outermost shell, it is metal. If I'm saying aluminium, 283, it is having 13 electronic atomic number, it is having 3 electron in the outermost shell. So it is having 3 electrons, so it is metal. Okay, likewise, if I'm saying magnesium is 2, 8, 2. So it is metal. Okay, lithium 2, 1, 2, 1, metal. Okay, so if an element is going to have 1 or 2 or 3 electron in their outermost shell, they are considered to be as metals. And if they are going to have either 4, 5, 6, 7, like carbon 2, 4, 4 electrons, like nitrogen 2, 5, like oxygen 2, 6, like fluorine 2, 7, like chlorine 287, like phosphorus 285. So these are all non-metal if they are having 5 electrons. But what do you mean by the word valency? Valency is the number of electron gained or lose or shared by an atom in order to attain stable electronic configuration to the nearest noble gas. Stable electronic configuration to the nearest noble gas. We considered it as atom. Sorry, valency. So if an element is going to have sodium, so its nearest noble gas is neon, that is 2, 8. So it will lose one of its electron. So its valency is 1, simple. Its valency is 1. If it is going to lose for potassium, the nearest noble gas is argon, 2, 8. comma 8. So it will lose one of its electrons. So its valency is 1. So for an element with aluminium, its nearest noble gas is also neon. That is 2 comma 8. So it will lose 3. So its valency is 3. So for metal, they lose 1 or 2 or 3 electrons. So their valency is 1 or 2 or 3. For non-metal, they might share 4 electrons. Like for example, it started from 4. So what will happen? Neither it will lose 4, nor it will gain 4. Why it is so? Why they will not lose 4, not gain 4? It is very difficult. That we're going to discuss in the next class. Sorry, not in the next class, in the next higher classes. But I'm not going to explain you here that why if an element is going to have 4 electrons, why cannot lose 4, all 4, and gain all 4. So it is, but it will share. What do you mean by the difference between the sharing and gaining? Sharing means just understand earlier that what is sharing. They will share. Now, for example, if I'm saying an element is going to have 5, so it will not lose 5. It will gain 3. Okay, like phosphorus. Phosphorus has electronic configuration 285. So it will not lose 4. Sorry, 5. It will gain 3. And its nearest noble gas will be 2 comma 8 comma 8. That is argon. So it will not lose 5. It will gain 3. So its valency is 3. So for an element which is going to have 7 electron in its outermost shell, it will not lose 7 electron. It will gain 1, 2, 287. It will gain 1 electron to attain its stable electron configuration, that is of argon. So 7, if it is having 7, the valency is 1. If it is having 6 electron, the valency is 2. If it is having 5 electron, then valency is 3. If it is having 4 electron, then valency is 4. If it is having 3, then it will lose all 3. The valency is 3. So valency lies between 1, 2, and 3. 4, not 5. But in the higher classes, you will learn that some element shows 5 valencies. That is a exception case. But up to 20 element, you need not to worry. You have to concentrate that the non-metals, if they are having 7 electron in their outermost shell, they can have valency 1. Because 7 require only 1 electron to complete its octet. So they can be metal or non-metal, either metal or non-metal both. Understood? Yes or no?
Yes.
Yes, sir.
The first model of atom was given by J.J. Thomson. This was correct, 13.
Yes, sir.
Yes.
Next is 14. An atoms with 3 proton and 4 neutron, 3 proton and 4 neutron will have tendency of, tell me,
1.
1.
1. Let me check. What is valency? 3 proton. So 2 comma 1. Yes, electronic configuration will be 3 because proton indicate that the same number of electron also, because it is saying atom. Atom is electrically neutral, not ion. So it is saying 3 proton means 3 electron will be also there. If 3 electron means you will arrange them like 2 comma 1, then its valency is 1. Simple. Distribution of aluminium is 283. A. Got it?
Yes, sir.
Yes.
Next one. Next one is 16. How many of you have done 16 correctly? So it is saying the Bohr model atom not do not represent. So do not.
C.
So this one is not going to represent the Bohr model because it is having 4 electrons in its first shell. And this one, I think 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 electron cannot be represented in the second shell or in the last shell. If it is the last shell, then it cannot have more than 8 electrons. So simple. Third and fourth. Third and fourth is the correct option. Got it?
Yes.
They will
Yes,
not
sir.
represent it. Okay. Then done 17 also.
Yes, sir.
17 is correct, everyone.
Yes, sir. Correct.
Yes, sir.
Yes. Sir.
Okay. Electron and proton are equal. 18 is also correct. We have discussed this one.